Hi, I'm Mr. Bullock with B&B Test Prep. This short video is going to be on Pythagorean triples. The SAT test makers have become addicted to these Pythagorean triples, so I think it's worthy to do this short video on this. So, it deals with the Pythagorean theorem and right triangles, and everybody's done the right triangle, the Pythagorean theorem before. A squared plus b squared equals c squared. Just make sure that c is always opposite the right angle right there. So, let's try a couple of these right here. Is this a right triangle? Is 2 squared plus 3 squared equal to 4 squared? If it is a right triangle. If it's not, then it's not a right triangle. And 4 plus 9 does not equal 16. That's 13 right there. So that's not a right triangle. It's a triangle, it's just not a right triangle. So let's try another one right here. 3, 4, 5. Is 3 squared plus 4 squared equal to 5 squared? You get 9 plus 16. Yeah, that equals 25. In fact, this is the most common P triple, Pythagorean triple. It's called a 3, 4, 5 Pythagorean triple. I'm going to start calling them P triples from now on just to save some time. And if I multiply 3, 4, 5 times 2, 3 times 2, 4 times 2, 5 times 2, I get 6, 8, 10. It turns out that 6 squared plus 8 squared equals 10 squared. So 6, 8, 10 is another Pythagorean triple, a P triple. It's a multiple of 3, 4, 5. So multiply by 3, I get 9, 12, 15, and it turns out that every time I multiply a P triple by some constant number, I get other P triples of it. So here are 3, 4, 5 P triples, times 2, times 3, times 4, times 5. I can do this forever and ever, infinitely many times. They're all multiples of 3, 4, 5 P triples. Let's go different numbers, other P triples. 5, 12, 13. 5 squared plus 12 squared equals 13 squared. There's a squared right there. So 25 plus 144 equals 169. So that's a P triple. So if I multiplied 5, 12, 13 times 2, I get 5 times 2, 12 times 2, 13 times 2. That's another P triple. It's a multiple of 5, 12, 13 times 3, times 4, times 5. Those are all multiples of 5, 12, 13 P triples. Okay, let's do some other P triples that come up on the SAT a lot, you guys. 8, 15, 17 is another P triple. 8 squared plus 15 squared equals 17 squared. And so if I go times 2, times 3, times 4, times 5, here is 8 times 5, 15 times 5, 17 times 5. These are all P triples. They're multiples of 8, 15, 17. So let's do some more P triples, you guys. 8, 15, 17, 7, 24, 25 is a common P triple, you guys. So if I had this triangle, say I had a triangle right here, you guys, and they told me it was a right triangle, and they told me that this side was 25 and that side was 7, find that. Well, I know it's 24. You can do the Pythagorean theorem if you want. It just saves yourself some SAT testing time to know these P triples. Yeah, 7 squared plus x squared equals 25 squared. And crank out your algebra if you want, or just know your Pythagorean triples. Save some time. This one's been popping up lately, 9, 40, 41. There's infinitely many more. I have a big list of them. If you want a big list of them, I'm happy to email it to you if you want. Just give us an email at bb@bbtestprep.com. and I'll email you a list of a lot of them. There's infinitely in it. Let's try some examples. Okay, I have this figure right here. It says in the figure, what's the length of OH? So I need to find this length right here. So I have some right triangles here. If that's a right angle, that's a right angle right here. This is 3 times 3. This is 5 times 3. So this must be 4 times 3, a 3, 4, 5 multiple of a right triangle. So 4 times 3 is 12. And then look at this triangle. This is 5, 12. Remember what that one is? It's 13. So what's the length of that? It's choice B. Okay, let's try another one. Excuse me. Okay, I have this right triangle inscribed in the circle that has radius 26 and one of the legs is 20. Find the area of that right triangle. All right, let's put some the stuff inside of there. There's my right angle. I made this length 20. Okay, now if the radius is 26, then the whole diameter is twice that, so it's going to be 52. Okay, and that ends up being a nice multiple of 5 times 4 is 20, 13 times 4 is 52, so if I multiply the 12 times 4, I get that other leg of that right triangle to be 48. So here's my right triangle right there. Now I know that that length's 52, but I don't need that anymore because they want to know the area, and the area of a right triangle is half. Don't forget the half. Half base times height. and this is my base, this is my height, so I get 480. And whatever the units are, it's square units, but you don't need to worry about that on the SAT, but centimeters squared or whatever. Okay, let's try another one here. Have this rhombus, you guys. A rhombus has side 5 centimeters and one of the diagonals is 6. Okay, first of all, a rhombus, you guys, is it's like a square being squished over. It's an equilateral, quadrilateral. So one of the diagonals is 6, so find the length of the other diagonal and then the area. Well, once I find that, this one's easy, you guys. I'll show you. Okay, so here's my rhombus, 5's going around, and there's one of the diagonals. Well, it turns out a rhombus is a parallelogram, so when I draw that other diagonal, that's what we're looking for, is this length right here. The diagonals bisect each other, so I'm going to cut them up into 3 and 3 instead of 6, and x and x. And it also turns out that the diagonals on a rhombus are perpendicular, so that's a right angle right there, so I have a 3, 4, 5 right triangle. So if it's a 3, 4, 5 right triangle, so that must be 4, that must be 4, so the whole other diagonal is 8. Okay, and then the area of a rhombus is you multiply the diagonals and take half of it. It is half the product of the diagonals. So I go half of 6 times 8 and I get 24. I think it was centimeters and centimeters squared.